Commuting to work, heading to the gym, or maybe just grabbing a quick revision break. Perfect, because in this deep dive, we're going to simplify one of the most conceptually demanding and definitely one of the most tested areas in management accounting: standard costing and variance analysis.
That's absolutely right. Performance management, PM, it really hinges entirely on your ability to judge how well you actually performed compared to the plan you set out.
Yeah.
And standard costing, well, it's the indispensable mechanism, really, that gives you that precise objective benchmark to measure against.
Right. And our mission today, just to be really clear, is explicitly non-numeric. We are deliberately bypassing the heavy calculation side. So no formulas, no spreadsheets, none of that step-by-step math. We are drilling down solely into the logic, the intuition, and I think most importantly, why these variances actually matter for managers on the ground. We want you to really get the philosophy behind the numbers.
Yeah, because management accounting, fundamentally, it's all about control and decision-making. That's its purpose. But look, to control anything effectively, you first have to define what success looks like, right? If you just, say, compare your current costs to what they were last year, you're kind of baking in all of last year's problems and inefficiencies. You haven't really set a target. You need a proper yardstick, a measure of what costs should be under efficient operation. And that shift, that move from just looking backwards at historical data to setting a forward-focused standard, well, that's the real power of this whole system.
Okay, so let's unpack that foundational concept then. Standard costing itself. When we use the word standard here, we're not talking about like average costs, are we? What's the fundamental definition we need to work with?
No, not average at all. At its very core, standard costing is an accounting system built entirely on the idea of predetermined costs and revenue per unit. So we're basically fixing the expectation. We're deciding up front how much resource, how much time, how much money should go into making one unit before production even starts. And this predetermined cost, the standard, it then functions as the objective benchmark. It's what you measure against. Every dollar you actually spend, every hour of labor actually used gets judged against this standard. And that gives you immediate, useful feedback for management.
Okay, so it's not just a high-level budget number like, okay, team, we can spend $500,000 this month. It's much more granular than that. It's a bottom-up thing, like a micro budget for every single item that comes off the line. That sounds like it implies incredible detail. So how do you pull all that together? How do you synthesize all that detail into one single expected cost for one product?
Yeah. That takes us straight to the standard cost card. You should think of this card as the perfect recipe for making your product. Or maybe a blueprint. It's quite formal. It details the precise inputs needed. So the standard quantity of materials, the standard price for those materials, then the standard time for labor, the standard rate you pay for that labor, and also the predetermined absorption rates for overheads, both variable and fixed. The card then pulls all this together, culminating in the total standard cost of production for one unit, and even the target standard profit per unit. It really just formalizes the entire expectation.
Right, the blueprint. Let's look a bit closer at the ingredients in that blueprint then, because this structure is absolutely foundational for understanding variance analysis later on. Starting with direct materials, the physical stuff, what two variables do you need to fix in advance there?
Okay, for materials, you've got to fix the physical amount and the cost of that amount. So first is the standard quantity. This is how many kilograms or liters or whatever unit of raw material should go into making one single finished product. And crucially, this quantity, the standard, it has to already allow for normal, unavoidable waste, things like scrap or a bit of spoilage. You're setting an attainable physical limit, not an impossible one. And second, you need the standard price. This is what you expect to pay per kilogram or per liter for that material. And you'd factor in things like expected bulk discounts, market rates you anticipate for the upcoming period.
And simple maths then. Multiply that standard quantity by that standard price, and boom, you've got your standard material cost per unit. But even that simple structure, it immediately sets up two different areas of accountability, doesn't it?
Exactly. Straight away. The standard quantity that sets the physical target for the production team. The manager is responsible for the actual making of the product, for minimizing physical waste. While the standard price, that sets the financial target for the purchasing department, the people whose job it is to source materials and negotiate the best prices. So see, we've already split the responsibility before we've even started making anything.
Okay, that makes sense. Then we move on to the second direct cost, labor, the human effort involved.
Labor follows exactly the same logic. Identical, really. You define the standard time, so the number of hours of direct labor that should be spent making one unit. And again, you have to be realistic. You account for normal rest breaks, maybe a bit of fatigue allowance. It's not flat out maximum speed. And then you define the standard rate, what you expect to pay per hour for the specific grade of worker needed for that task. That might be based on union contracts or local wage agreements, whatever's relevant. Multiply those two times standard rate, and you get the standard labor cost per unit. Again, you're setting targets. One for efficiency, how much time is spent, and one for cost control, what rate is paid.
Got it. Materials and labor are fairly straightforward because they're direct. You can see them going into the unit, but then we hit overheads. These are always trickier, aren't they? Because they aren't directly linked to a single unit in the same way, things like factory rent or supervisor salaries, yet they still have to be incorporated into this standard cost card somehow.
Oh, absolutely they must. Especially if the organization uses absorption costing, which many do for reporting. For overheads, both the variable ones and the fixed ones, the standard cost card relies on using predetermined absorption rates. So, for variable overheads costs like electricity for machines or indirect materials, things that do fluctuate with activity, we often link them to the direct labor driver. We assume more labor hours mean more variable overhead. So we take the standard time, let's say it was 1.5 labor hours per unit, and we multiply that by a predetermined variable overhead absorption rate, say $6 per hour. This effectively links a variable cost, like power consumption, directly to the output unit based on the standard time it should take to make it.
Okay, that covers variable. But what about fixed overheads? The big ones like rent, insurance, depreciation. These costs don't change whether we make 1 unit or 1,000 units. How do they end up on the card?
Conceptually, the mechanic is the same, but the purpose here is different. It's all about absorption for inventory valuation and profit reporting. For fixed overheads, you take the standard time again, say 1.5 hours, and multiply it by a predetermined fixed overhead absorption rate, maybe $10 per hour in this case. Now, this isn't saying the unit costs $15 of fixed cost. It's purely a mechanism to ensure that for every unit we produce, we are allocating or recovering a planned portion of our total fixed cost budget. That $15, $10, 1.5 powders is theoretically attached to the unit for costing purposes. The really big takeaway here is how the standard cost card transforms the entire expected cost structure, direct, indirect, variable, fixed into this highly detailed, controllable sequence of unit-based expectations.
Right. It basically sets the non-negotiable definition of what good looks like for the upcoming period. It's the benchmark. Hashtag tag 2 YSET standards. Purpose and philosophy. Okay, so we've established how this detailed standard cost card, this blueprint. Now let's dig into the why. Why would a company go through all the administrative hassle, the effort of calculating these sort of perfect unit-level recipes? What's the core philosophy driving this whole approach?
Well, the fundamental philosophy, as you'd find detailed in management accounting texts, really revolves around two main pillars: planning and control. Those are the big ones. Firstly, planning. Standard costs are just an essential tool for putting together a solid budget. It makes budget preparation much easier. Think about it. If you know that one widget should cost exactly $20.50 to make, then forecasting the total cost for producing, say, 50,000 widgets becomes pretty simple multiplication.
Right.
It makes the whole budgeting process more robust, more reliable, and frankly, a lot quicker.
Okay, so robust planning, that's step one. Makes sense. But the real value, the reason we're really focusing on this today is probably step 2. Control and performance measurement.
Precisely. That's where the rubber hits the road. Standard costs are absolutely fundamental for budgetary control and for performance measurement. They create that indispensable feedback loop we talked about. You run production, you incur your actual costs, you pay your actual wages. Then you measure those actuals against the standards you carefully set beforehand. This comparison immediately highlights deviations, the variances, and that allows managers to see where things are drifting off course and, crucially, intervene to correct it.
So that's the main function, the control aspect. But the source material also outlines several other, maybe more strategic uses that go beyond just managing efficiency on the production line day to day. What other value does having a standard cost provide to the business?
Yeah, there are definitely other benefits. One major strategic use is in inventory valuation. Think about valuing your stock. If a company used its actual fluctuating cost to value inventory, that value could swing wildly day to day based on temporary issues. Maybe a machine broke down, maybe someone negotiated a bad price for one batch of material, it would be chaotic. Using a standard cost provides a consistent, stable basis for valuing work in progress and finished goods inventory. That stability is really important, both for internal tracking and definitely for external financial reporting. It gives clarity.
Okay, stable inventory values. How does this perfect recipe help out the sales or marketing folks?
Well, it aids significantly in pricing decisions. If you know your standard costs, the cost you should incur under normal, efficient operations, it gives you a rational, stable floor for setting your selling prices. If you were trying to base prices on volatile actual costs, you might accidentally include some high temporary inefficiency in your calculation, making your product suddenly uncompetitive. Or maybe worse, you might fail to price in legitimate long-term cost needs. Standard costs help ensure your pricing reflects attainable efficiency, not temporary chaos.
And we shouldn't overlook the human side, the behavioral aspect. Standards act as targets for people.
They absolutely do. Standards can be really potent tools for motivation. When you set targets that are clear, specific, and ideally attainable, something like reduce your material scrap rate to 2%, you give staff measurable goals to aim for. However, and this is a big however, the success of this motivation depends entirely on the psychological impact of the type of standard you choose to set. And this brings us to a really critical point: the different flavors of standards that exist. You have to choose the right one.
Yes, this is where, for anyone studying ACCA PM, you need real clarity. Because picking the wrong type of standard can fundamentally change the whole culture of your control system. The material usually details about 4 main types. Let's start with the theoretical extreme, ideal standards. What are those?
Right. Ideal standards. Think of these as theoretical perfection. They assume absolutely optimal conditions, maximum possible efficiency, zero waste, zero machine downtime, materials always bought at the absolute lowest possible price point. They represent essentially utopian performance, what could be achieved if everything went perfectly all the time.
Okay, sounds ambitious. But if they represent perfection, why are they often considered not very useful for routine variance analysis, for day-to-day control?
Well, simply because they are almost completely unattainable in the real world. A factory just cannot run at 100% perfect efficiency all the time. It's impossible. So if management insists on comparing actual performance day in, day out against an ideal standard, guess what happens? The resulting variances will always be massively adverse, always negative, and that's incredibly demotivating for both staff and managers. They know they're being measured against a standard they can never possibly achieve. They feel set up to fail. So while ideal standards might be useful for very long-term strategic goals, maybe they don't really help with operational control week to week.
Okay, so ideal standards may be inspiring, but not practical for routine management. Set those aside. Then we have basic standards. What's the defining characteristic there?
Basic standards are kind of the opposite extreme in a way. They are fixed over a very long period, sometimes years, and they essentially just serve as a historical yardstick. They let you see cost trends over a long, long time. They represent the long-run underlying average costs from way back when they were set, the big problem. They lack timeliness, they lack currency, they don't reflect current conditions at all. They might only be useful in environments where technology, wages, and market prices are incredibly stable, which is pretty rare these days. So
Yeah.
for real-time control, they offer very little value.
Right, not very dynamic. So that brings us to the practical choices that most companies actually use for management control: expected standards and current standards. Let's focus first on the really popular choice: expected standards.
Yeah, expected standards are really the workhorse for routine variance reporting in most companies around the world. They are set for a specific budget period, like a year, and they're based on normal, efficient operating conditions. The key word there is normal. They deliberately allow for a reasonable, budgeted amount of what you might call normal inefficiency, minor machine downtime that happens, a bit of unavoidable waste that's typical for the process. They're designed to be fair. They're meant to be met under normal, achievable conditions.
That sounds pretty balanced. Good for routine reporting, seems fair. But I remember reading a caveat, a potential downside. If they're too easy to meet, they might not actually be very motivating.
Exactly. That's the potential trap. If a standard just reflects normal past performance, a manager might hit that target pretty easily, maybe even coast a bit, and then stop pushing for improvement. They satisfy the benchmark, sure, but they don't necessarily drive that crucial element of modern management: continuous improvement. The goal can accidentally become just meet the budget rather than maximize our potential.
Okay, so expected standards are common, but maybe not perfect for driving improvement. Contrast that with the other practical option: current standards. These sound like they aim for maximum fairness.
Yes, current standards represent the current attainable standard. They are updated frequently, maybe even monthly or quarterly, to reflect the actual existing conditions of the period you're reviewing. So, if a new, more efficient machine was installed last month, the standard time allowed per unit is immediately lowered for next month. If there was an unexpected wage increase mandated by law, the standard labor rate is adjusted right away. They represent what a competent manager could and should achieve right now, given the current reality.
From a pure performance appraisal point of view, these sound like the best, don't they? They really measure management skill against the current specific situation. But what's the big practical drawback? Why aren't they used all the time?
The administrative cost and effort, that's the killer.
Yeah.
If your operational environment changes frequently, you get new suppliers, the quality of materials fluctuates, you have technological updates happening, you have to continually update the standard cost card. And that calculation and revision process takes time and resources. It can kind of defeat the administrative efficiency that standard costing is partly supposed to provide in the first place. So management faces a trade-off. They have to balance the desire for perfect, up-to-the-minute fairness, which points towards current standards, against the practicality and cost of constantly recalculating everything, which often makes expected standards more appealing.
So the choice of standard really sends a message. It dictates the psychological contract almost. Pick ideal, and you're signaling ultimate ambition. Pick expected. You're signaling stability and routine control. Pick current. You're signaling fairness, but demanding responsiveness. Right, so we've set our perfect standard, whichever type we chose. We run production for the period, we incur actual cost, actual hours are worked. Now we get to the moment of truth, looking for the gap, the variance between plan and actual. But before we even start splitting that total variance into different types, we absolutely have to address the single most crucial conceptual step in the whole process, the flexed budget. Why is it so vital that every comparison must be against the flex budget and not the original fixed budget we set at the start of the year?
This is completely non-negotiable if you want fair control. Absolutely critical. Think about the original budget, the fixed budget. It was probably prepared months ago, right? And it was based on a planned level of activity. Let's say the plan was to produce 10,000 units. But what if, during the period, the company actually produced and sold 15,000 units because demand was higher? If you just compare the total actual costs incurred to make those 15,000 units against the budgeted cost for making only 10,000 units, well, it's a recipe for disaster. The comparison is meaningless. The resulting total variance would be a complete jumble. It would mix up differences in spending efficiency and the simple fact that you produced 50% more stuff.
Which tells you absolutely nothing useful about how efficiently you manage the cost for the units you actually did produce.
Exactly. It's apples and oranges. The flexed budget fixes this. It adjusts the original plan to the actual level of activity achieved. It asks the simple, fair question. Okay, forget the original plan for 10,000 units. Given that we actually manufactured 15,000 units, what should it have cost us if we had perfectly met all the standards set on our standard cost card for each of those 15,000 units? By flexing the budget, essentially taking the standard cost per unit and multiplying by the actual number of units produced, we neutralize the effect of the volume change. It ensures managers are judged purely on their efficiency and their spending control for the work they actually delivered. It gets us back to comparing apples with apples.
Okay, so the flex budget is the true benchmark.
Yeah.
Standard cost per unit times actual output. That's the number we compare our actual total costs against. Once we have that overall total variance, the difference between actual results and the flex budget, why do we have to immediately break it down further? Why isn't just knowing the total difference enough?
Because the total variance, while important, it just hides the real story. It doesn't tell you why there's a difference. Management accounting principles are really emphatic on this. For control to be effective, variances must be analyzed into their constituent components. Let's say you have a total adverse variance of $20,000 on materials. Just knowing that number isn't very helpful for the CEO.
Right.
She needs to know why. Did that $20,000 difference happen because the purchasing department paid way more for the materials than they should have? Or did it happen because the production department was incredibly wasteful and used far too much material? Those are two completely different problems, right? They require two completely different managerial interventions targeted at different departments. The total variance doesn't give you that insight.
And that need for insight leads us directly to the ultimate purpose of doing all this granular analysis. It's not really about dwelling on the past numbers, is it? It's focused on future action.
Absolutely. The whole point is to investigate the reasons why the variance occurred, and then, crucially, to determine whether the underlying issues, the root causes, can actually be controlled in the future. Think about it. If a variance happened because of something totally outside the company's control, maybe the global price of a key commodity spiked by 40% unexpectedly, management needs to understand that. They can't directly control that global price. But, knowing that, they can plan how to mitigate the effect next time. Maybe they look into hedging strategies, or finding alternative suppliers, or redesigning the product. On the other hand, If the variance was due to purely internal factors like excessive waste on the production line, well, they can control that. They can implement immediate corrective action, maybe better training for staff, maybe improve machine maintenance schedules. The analysis directs limited managerial time and attention to the areas where it can actually have the greatest impact going forward.
Okay, got it. Now, before we dive into the specific types of variances, materials, labor, etc., let's just touch briefly on how the underlying accounting system choice, whether the company uses absorption costing or marginal costing, fundamentally changes which variances we even calculate, especially when it comes to fixed costs.
Yes, that's a really crucial conceptual hurdle for students to grasp. When a company uses marginal costing, the whole focus shifts away from calculating total profit per unit and focuses instead entirely on contribution margin. Remember, contribution is sales revenue minus variable costs only. Under marginal costing, fixed overheads are treated simply as period costs. They're lumped together and expensed in full against the period's total contribution, regardless of how many units were produced or sold.
Right. And because, under marginal costing, we aren't trying to attach fixed costs onto each individual product unit,
Mhm.
a specific category of fixed cost variance just becomes irrelevant, doesn't it?
Correct. The entire process of absorbing fixed overheads onto units, using those predetermined rates we talked about earlier, is just ignored under marginal costing. It doesn't happen. Therefore, the fixed overhead volume variance, which specifically measures the financial impact of producing more or fewer units than budgeted, leading to over or under absorption of fixed costs, is simply not calculated. It's not relevant to the marginal costing world. When using marginal costing, the only fixed overhead variance we generally care about is the fixed overhead expenditure variance, which is just a simple check. Did we spend more or less total cash on all our fixed costs during the period than we budgeted to spend in total? That's it.
Okay, now for the real core mechanism, splitting that total difference between actual costs and flexed budget cost into actionable, understandable components, we need to really get into what each basic variance is telling management. Not the calculation, but the message. We should probably start where the product itself starts, with direct materials.
Makes sense. And the key thing to remember with materials, as we hinted at earlier, is that the total material variance is immediately split into two distinct parts. And importantly, these usually assign responsibility to two different departments.
Okay, so the first split is the material price variance, often abbreviated as MPV. What exactly is this measuring, and typically who owns this variance?
Right. The MPV measures the difference between the standard price we expected to pay for materials and the actual price we did pay for the quantity of material we actually purchased during the period. This variance is typically considered the responsibility of the purchasing department or the procurement team. It directly answers the question, did we manage to buy the materials we needed at the expected cost per kilogram, per liter, per unit, or did we overspend or underspend on the price?
Let's explore some reasons why you might get an adverse MPV, meaning you paid more than the standard price. It's probably not always just because the market price went up, is it?
No, you're absolutely right. An adverse MPV paying more than standard could happen for several reasons. Sure, it could be a genuine, uncontrollable global market price increase for that commodity that just wasn't forecasted accurately. That happens. But it could also be down to management actions or inaction. Maybe a failure to secure expected bulk discounts, perhaps because orders were placed too late or in smaller quantities than planned. Or perhaps the company had to use an alternative supplier, maybe a more expensive one, because the usual preferred supplier couldn't meet the delivery schedule for some reason. It could even be down to things like incurring unexpected transportation costs, needing rush shipping to meet a production deadline, for instance. So it's really a measure of the purchasing function's cost control effectiveness.
Okay, so that's adverse. Conversely, a favorable MPV means the purchasing manager seemingly got a better deal, they paid less than the standard price. But, as we kind of discussed earlier, a favorable result isn't automatically a good thing for the company overall. And this connects directly to the second material variance,
Yeah.
the material usage variance,
Yeah.
MUV.
Exactly. The MUV, this is squarely aimed at the production floor or the factory manager. It's about the physical handling of the material. It measures the difference between the standard quantity of material that should have been used for the actual output achieved based on the standard cost card recipe and the actual quantity of material that was really used. This variance directly answers the question, were we efficient with our materials? Did we use more or less physical material kilograms, liters, than the blueprint said we should have needed for the number of units we actually produced?
So this variance is a direct signal of physical efficiency on the shop floor. Or, more commonly perhaps, if it's adverse, it signals problems with waste or spoilage. What are the common root causes for an adverse MUV, meaning too much material was used?
Yeah, an adverse MUV means excessive physical consumption of material. Common causes include things like poor workmanship. Maybe workers are less skilled or less careful and they drop or spoil materials. It could be faulty machinery, perhaps machines are incorrectly calibrated or maintained, leading to excessive cutting waste or scrap. Or, and this is the really critical linkage back to the price variance, it could be caused by using lower quality material. Remember that favorable MPV the purchasing manager might have achieved. If they got that by buying cheaper, substandard material, that poor quality might then require the production team to use more of it, a higher quantity, to achieve the final product specification. Maybe it breaks more easily, maybe more needs to be trimmed off the result. A large adverse MUV on the production floor directly caused by the purchasing decision.
Oh, okay. So the management team absolutely must look at these two variances, price and usage together. They tell a connected story. A manager focusing only on achieving a favorable price variance might be, completely unintentionally, causing massive losses downstream through an adverse usage variance. And that usage variance cost could easily wipe out the initial price saving. This sounds like that classic management problem of some optimization, right? Improving performance in one little area, but actually harming the overall performance of the whole organization.
Absolutely. That's a perfect example of it. The manager's job isn't just to look at the numbers in isolation on a report. It's to investigate the chain reaction, the potential trade-offs. If the MPV is favorable, great. But if the MUV is adverse, the very first question should be, okay, why did we use too much material? Did the purchasing manager compromise on quality to get that low price? You have to connect the dots.
Makes perfect sense. Okay, let's move on from materials to direct labor, which logically also splits into two key variances. One about the price, the rate paid, and one about the quantity, the time taken.
That's right. The first is the labor rate of pay variance. This answers the question, did we pay our workers more or less per hour than the standard rate we set in the standard cost card? Just like the material price variance, this is primarily a measure of cost control. And typically, the responsibility for this doesn't lie with the worker themselves, but more with the HR department or perhaps the operations manager who does the scheduling and staffing.
Okay, so what sort of things drive an adverse labor rate variance, meaning we paid more per hour than planned?
Well, the primary drivers are usually managerial decisions about staffing or sometimes unforeseen market shifts affecting wages. Firstly, it could be due to using a different grade of labor than was planned for the task. For example, if a standard machine operator calls in sick, and maybe a higher paid supervisor has to step in to run the machine for a shift to keep production going, their higher hourly rate causes an adverse variance. Secondly, it could be an unexpected, unbudgeted wage increase. Maybe a new union agreement came into effect mid-year, or market rates for certain skills went up suddenly. Thirdly, it could even be due to misallocation of workers. If you have a highly skilled, highly paid worker doing a relatively low skill task that was budgeted at a lower rate, that mill match will create an adverse rate variance. Essentially, it tells management they paid too much for the specific hours that were worked.
Got it. Then the second labor variance is the labor efficiency variance. This sounds like the direct physical productivity measure for labor, the parallel to the material usage variance we just discussed.
Correct. The labor efficiency variance answers the question. Did the workers take more or less time, more or fewer hours to produce the actual output achieved than the standard time specified in the cost card? So if the standard allows, say, 10 hours of labor to produce 100 units, but the workers actually took 12 hours to make those 100 units, the efficiency variance is adverse. It's the core metric for labor productivity. How fast do they work?
And what kinds of things cause poor labor efficiency, leading to an adverse variance? Why might workers take longer than standard?
Oh, there can be many reasons. It could be related to poor worker morale or motivation, maybe leading to slower work or more mistakes needing rework. It could be due to machine breakdowns or poor maintenance. If machines are constantly stopping, workers are forced to wait, becoming inefficient through no fault of their own. It might be down to poor scheduling or supervision, perhaps leading to wasted time waiting between jobs or unclear instructions. And critically, just like with materials, it could be caused by poor quality materials. If the materials provided are faulty or difficult to work with, workers might have to spend extra time fixing problems, compensating for the poor quality, or just working more slowly to avoid defects. Their efficiency drops. So again, we see that potential interlinkage. An adverse material usage variance, maybe caused by cheap materials, could easily lead to an adverse labor efficiency variance as workers struggle with it.
You also mentioned earlier briefly the slightly more advanced concept, but one that's highly relevant in some industries, the idle time variance. Why is this sometimes calculated and reported separately from the main efficiency variance?
Right, the idle time variance is conceptually quite interesting because it specifically focuses on splitting the time we paid workers for from the time they were actually productively working. Idle time happens, right? Time can be lost due to external factors like power outages or internal issues like machine breakdowns or waiting for materials to arrive. This lost time is often unavoidable to some extent. An idle time variance only occurs if the actual amount of idle time suffered during the period differs from the amount of idle time that was budgeted or allowed for in the plan.
Ah, okay. So if management budgets for, say, 50 hours of lost production time per month for routine machine maintenance, and this month they managed things better and only actually lost 30 hours to maintenance, they'd get a favorable idle time variance.
Exactly. It would signal that they managed their operational capacity and risks better than they had expected or planned for. Conversely, a large adverse idle time variance is a huge warning light for management about capacity utilization and operational problems. It means significantly more production time was lost than planned time, for which workers were likely still paid, directly impacting the factory's output capability. It highlights disruptions.
Okay, that clarifies idle time. Let's shift our focus now to the overheads. We'll start with variable overheads. You mentioned these are often absorbed based on the same driver as direct labor, usually direct labor hours worked.
That's very common, yes. And because they often follow the same physical activity driver, labor hours, their variances conceptually mirror the labor variances we just discussed. But instead of focusing on the cost of labor itself, they focus on the other costs associated with running the factory per hour of activity.
Okay, so following that logic, the first variable overhead variance would be the variable overhead expenditure variance. What's that telling us?
This is basically our cost control measure for variable overheads. It asks the simple question, did we spend more or less per hour on all those variable overhead items, things like indirect materials, machine power, lubricants, small consumables, than the standard variable overhead rate we set per hour? It's essentially a rate or price variance, but focused on those indirect variable inputs. An adverse variance suggests maybe electricity rates went up unexpectedly, or perhaps indirect supplies were used less efficiently per hour worked than planned.
And following the labor parallel, the second one must be the variable overhead efficiency variance. You mentioned this one is often seen almost as a side effect of the labor efficiency variance. Why is that?
It really is a direct, almost arithmetical consequence in many systems. The variable overhead efficiency variance is driven by the exact same underlying physical efficiency measure as the labor efficiency variance. If the labor force worked 100 hours less efficiently than standard, an adverse labor efficiency variance, it automatically means the factory was running for 100 hours longer than it should have for the output produced. Therefore, it must have consumed more variable overheads, like power, during those extra 100 hours. This must result in an adverse variable overhead efficiency variance, calculated simply as those extra hours multiplied by the standard variable overhead rate per hour. It just confirms that when labor is inefficient, takes too long, all the related variable resources consumed during that time are also used inefficiently, and vice versa if labor is efficient.
Okay, variable overheads seem to follow labor logic closely. We've covered all the variable cost elements now, materials, labor, variable overheads. Now we have to tackle the area that often causes the most conceptual difficulty: fixed overheads, particularly under absorption costing. This is where that distinction between just spending money and effectively utilizing our capacity to absorb those costs becomes really critical. You mentioned the total fixed overhead variance is often split in three parts: under absorption costing.
Yes, typically 3 under absorption costing, and we do this because fixed costs, think of things like factory rent, manager salaries, annual insurance premiums, depreciation on machinery. These are usually budgeted as big total lump sums for the period. They don't change directly with output. But under absorption costing, we try to recover or absorb these large fixed costs by attaching a piece of them to every unit we produce, using that predetermined fixed overhead absorption rate per hour or per unit. The goal, implicitly, is to ensure that the volume of production we achieve is high enough to earn back or absorb the total amount of fixed costs we budgeted to spend. The variances help us see if we achieve that.
Right. So of the three splits, the easiest one conceptually is probably the fixed overhead expenditure variance. What does that focus on?
Yeah, this one ignores production volume and absorption rates entirely. It simply asks, did we spend more or less total cash or incur more or less cost on all our fixed overhead items this period than the total lump sum we budgeted for them at the start? Did the factory rent go up unexpectedly? Did we hire an extra supervisor whose salary wasn't in the original budget? Did insurance premiums increase? It's a straightforward budget versus actual comparison of the total fixed spending.
Yeah.
Did we overspend or underspend the fixed cost budget in absolute terms?
Okay, simple enough. Now, for the two variances that are all about volume and absorption, the capacity variance and the efficiency variance, these often get confused. Let's tackle the fixed overhead capacity variance first. What is this measuring?
Yes, this is a major area of potential confusion, so let's try to be really clear. The fixed overhead capacity variance measures the financial impact, using the fixed overhead absorption rate, of the difference between the actual hours worked in the factory and the budgeted hours available or planned to be worked. This variance is fundamentally a measure of factory utilization or activity level utilization. Did we use the time we had planned to use?
So it's basically asking, did we run the factory, did we keep the machines turning for as many hours as we intended to in our budget?
Exactly. It tells management. Did we operate the factory for more hours or fewer hours than we originally planned or budgeted for? For instance, if the budget assumed the factory would operate for 4,000 hours during the year, but due to, say, a major supplier strike causing material shortages or maybe just a slump in sales orders, we only actually ran the machines for 3,800 hours. That difference of 200 hours represents underutilized capacity. We failed to work the hours we budgeted. This results in an adverse capacity variance, calculated as 200 hours times the fixed overhead rate per hour. It signals a potential failure in areas like demand forecasting, production scheduling, or maybe even supply chain management. It represents the cost of having expensive machinery or a whole factory sitting idle when it was planned to be working.
Okay, so capacity variance is about whether we worked the budgeted hours.
Right.
That leaves the final piece, the fixed overhead efficiency variance. What does this one tell us?
Right. The efficiency variance focuses on the productivity during the actual time we did spend working. It measures the financial impact, again, using the fixed overhead absorption rate, of the difference between the actual hours worked and the standard hours that should have been worked for the actual production volume achieved. Crucially, as you might guess, this variance links back directly to the physical efficiency we saw in the labor efficiency variance and the variable overhead efficiency variance.
So putting it simply, if the workers were physically inefficient, meaning they took longer in actual hours than the standard hours allowed for the output they produced.
That's exactly it. If the workers were inefficient on the shop floor and maybe it took 5,000 actual hours to complete a batch of work, that, according to the standard cost card, should have only taken 4,500 standard hours. That difference of 500 inefficient hours multiplied by the fixed overhead absorption rate per hour results in an adverse fixed overhead efficiency variance. What it means is that even though the factory was running, we use those 5,000 actual hours, it was running slowly or inefficiently. As a result, we failed to absorb our fixed costs at the planned rate per unit simply because we didn't generate enough standard hours of output for the actual time the factory spent operating.
Okay, let me try and summarize that critical distinction then, because it is tricky. The fixed overhead capacity variance looks at volume relative to availability, basically. Were we running the factory for the number of hours we planned to? Did we utilize our available time? And the fixed overhead efficiency variance looks at volume relative to productivity, basically. During the hours we were running, how fast or efficiently were we working? Did we get the expected output for the time spent?
That is the essential managerial distinction you need to grasp. One variance, capacity, focuses on maximizing the use of the hours available. The other, efficiency, focuses on maximizing the output achieved during those hours worked. They diagnose different aspects of performance.
Okay, wow. We have meticulously broken down pretty much every basic variance into its logical components: price, usage, rate, efficiency, expenditure, capacity. But the real deep dive, the truly actionable insight that a manager needs, comes from the interpretation of these numbers. We really need to move beyond that simplistic, almost knee-jerk reaction of favorable F equals good and adverse A automatically equals bad. It's not that simple, is it?
No, absolutely not. That mindset shift is paramount for using variance analysis effectively. Favorable or adverse is merely a mathematical signpost. It tells you there's a deviation from the plan you set. It must never be taken at face value as inherently good or bad performance. A good manager must always ask the crucial follow-up questions. Okay, what caused this variance and what were the knock-on effects, the consequences across the entire system?
Let's maybe revisit that classic example we touched on, the potential interconnection, the trade-off between the material price variance, MPV, and material usage variance, MEV. This seems like the perfect illustration of why favorable isn't always good. The danger of managerial suboptimization.
It's a textbook case. Imagine a purchasing manager who is heavily incentivized, maybe through their bonus scheme, solely on reducing material costs. They go out and find a new supplier, negotiate hard, and achieve a large, highly favorable material price variance. On paper, on that purchasing report, that manager looks like a star performer, saved the company money. However, what if that cheaper material they bought has inconsistent quality? Maybe it's slightly brittle, maybe the dimensions aren't quite right. Back on the reduction floor, this cheaper material starts causing problems. It gums up the machines, forcing more frequent stops. It requires constant adjustment by the workers. And ultimately, it leads to significantly increased scrap, more spoilage, higher levels of waste.
Resulting in a potentially catastrophic, highly adverse material usage variance. And the cost of that extra waste could easily be 10 times larger than the initial saving on the purchase price.
Exactly. So the overall result for the company is actually a massive net loss, stemming directly from what initially looked like an isolated, positive, favorable variance in purchasing. And it might not stop there. If the production workers had to slow down significantly to deal with that inferior material, you'd probably also see an adverse labor efficiency variance because they took longer than standard. And consequently, an adverse variable overhead efficiency variance too. That favorable MPV was actually a lagging indicator of a financially detrimental decision made upstream. Managers absolutely have to investigate the entire chain of consequences. They need to prevent isolated departments from just optimizing their own numbers on their own reports, potentially at the expense of the overall organization.
Yeah, that really highlights one of the major inherent limitations, or at least dangers, of using traditional standard costing too rigidly. The risk of quantitative overemphasis, what some people call the budgetary trap.
That's right. Management accounting literature often points out that standards, if they're enforced too rigidly without context, can lead to managers focusing intensely, maybe obsessively, on just hitting the quantifiable numbers, meeting the budget targets, getting those favorable variances, even if it means sacrificing crucial qualitative measures. This includes things like maybe delaying essential machine maintenance to avoid showing an adverse fixed overhead expenditure variance this month, only for the machine to break down completely next month, causing a massive idle time variance and lost production. Or maybe rushing production towards the end of the month just to hit the labor efficiency targets, but in doing so, compromising product quality, leading to customer complaints and returns down the line. The system itself can risk becoming an end in itself, just about hitting the numbers, rather than being used as a means to achieve genuinely better quality, efficiency, and overall control.
And what about the suitability of the system itself? Does standard costing actually work well for every type of business, every operating environment?
Not really, no, particularly if the business lacks uniformity in its output. Standard costing fundamentally relies on the assumption of reasonably high volume, mass production of standard, homogeneous units. If a company operates more like a custom job shop, making bespoke, unique products for every single customer, think building a one-off super yacht or designing specialized industrial equipment, then trying to set a single standard cost card for one unit becomes incredibly difficult, very time-consuming, and often, frankly, irrelevant for control purposes. Standard costing is generally best suited for environments with repetitive manufacturing processes and standardized outputs.
Okay, and perhaps one of the most significant philosophical debates, especially in modern management accounting, is the apparent contradiction between traditional standard costing approaches and newer management philosophies, like total quality management, TQM, and just-in-time GIT production.
Yes, this is a really profound conflict, and something students definitely need to think about. Traditional standard costing, particularly when it uses those common expected standards we discussed, explicitly builds in allowances for a certain level of inefficiency. It budgets for, and therefore implicitly accepts, a normal level of scrap material, a normal amount of idle time, maybe even a normal level of rework for defects.
Right, but TQM and JIT philosophies are all about the pursuit of perfection. They aim for continuous improvement towards goals like zero defects, zero inventory, and zero waste. They want to constantly challenge and lower the standard, not just meet it.
Precisely. There's the conflict. If your standard cost card says, for example, that 5% material waste is normal and acceptable, what happens when the production manager gets the waste level down to 4.8%? Under traditional variance analysis, they've achieved a favorable variance. They might stop investigating, stop looking for further improvements because they've met the standard. Traditional variance analysis often focuses attention only when you deviate significantly from the current standard. But TQM demands a perpetual focus on lowering the standard itself, on eliminating that 5% waste entirely, not just accepting it. So TQM demands continuous elimination of waste and inefficiency, while traditional standard costing often normalizes and budgets for a certain level of it.
So how does a company that's really committed to a TQM or continuous improvement culture use variance analysis effectively without undermining its own core philosophy?
Well, they often have to fundamentally adapt how they use the variance system, or maybe even the type of standards they set. Some companies might deliberately shift away from using expected standards and instead choose to use ideal standards for their routine reporting. Now, why would they do that, given we said ideal standards are demotivating? Because in a TQM context, the resulting variances will always be adverse. They will always show a gap between actual performance and theoretical perfection. And this constant, unavoidable adverse variance acts as a continuous reminder, a perpetual signal, a permanent incentive for managers and teams to engage in root cause analysis, find problems, and drive that incremental improvement. The standard itself transforms. It stops being just a benchmark for acceptable performance and becomes more like a motivational beacon, highlighting the journey towards perfection. The adverse variance isn't seen as failure, but as opportunity.
Wow. Okay, so the standard itself and the interpretation of the variance completely changes. It becomes a tool-driving change, not just measuring compliance. That requires a completely different managerial relationship with the numbers, doesn't it?
It absolutely does, and it really underscores the ultimate forward-looking managerial mindset that should underpin all variance analysis. Variances are not meant to be historical scores just to look back on. They are absolutely not designed merely as devices for blaming people or pointing fingers at departments when things go wrong. They are primarily tools for control.
Meaning the investigation, the why, not the number itself, is actually the most valuable part of the whole process.
Absolutely. That's where the learning happens. The manager's core responsibility isn't just to report the variance number, but to understand why performance differed from the standard. Was it fundamentally an input problem, something to do with the price or quality of materials or labor? Was it a throughput problem, an issue with efficiency, waste, or time taken during the production process? Or was it perhaps even a systemic planning problem? Maybe the original standards were flawed or the capacity planning was inaccurate. Once that root cause is identified, and crucially, whether it's controllable or uncontrollable, the manager's focus must shift to corrective action. How do we ensure the favorable results are sustained or built upon? How do we ensure the adverse results are mitigated or, ideally, eliminated in the next reporting cycle? It's all about future improvement.
So ultimately, this entire system, from building that detailed standard cost card recipe, through flexing the budget, to performing that layered analysis of variances like fixed overhead capacity versus fixed overhead efficiency, it's all designed for one purpose: to transform raw financial data into granular, actionable, accountable business intelligence. It provides that essential feedback loop that organizations need for effective operational control and for driving performance in line with their strategic goals.
And honestly, for anyone studying performance management, understanding that underlying managerial logic, getting the intuition behind why we split variances the way we do, is far, far more crucial in the long run than just memorizing the specific algebraic formulas for calculating them. Once you really grasp the why, the meaning behind the numbers, the calculations themselves become much more straightforward.
And that's our deep dive into standard costing and variance analysis. Really the key mechanism for turning those potentially dry numbers into powerful operational insights that managers can actually use.
Yeah, absolutely. And if this deep dive has helped you understand the managerial logic, the purpose behind breaking down these variances, then make sure you subscribe for more ACCA performance management lessons you can listen to anywhere, anytime.